Okay, students, so we all know what is rate. What is rate? For example, if I can eat 5 hamburgers in 1 hour, then how many hamburgers can I eat in 2 hours? So that's the rate, how fast I can eat hamburgers, right? Now, what about speed? Today we're going to do speed. So speed is very similar to rate. The only difference is that when you talk about speed, you're talking about how much distance, how far you can travel within a fixed amount of time. Okay? So that's the only difference between speed and rate. So let's see, how do we find speed? The most important equation for speed is speed equals to distance over time. And right from the start, I think it is important for us to know this triangle called the DST triangle. So let me teach you how to use this triangle, okay? DST triangle. Now, as you know, students, when we write a fraction, 1 over 2, then you know that this line, what does it mean? It means divide. So it means 1 divided by 2. So when you have a number on top and a number below, what does it mean? Take the number on top divided by the number below. So that's what it means. So if you look at this triangle, you notice that there's something on top, there's something below. Whenever you see something on top and something below, it means divide. So for example, speed equals to distance divided by time. You see here? Isn't it the same thing that they're telling you? Speed equals to distance divided by time. Now, if you want to find the time, you can do that too by using this triangle. Time, if you want to find time, it equals to distance divided by speed. Okay, students? So you just need to look at the triangle and find out what you need to find. Now, what if you want to find distance? Distance equals to, now look at the speed and the time. They are side by side. So when they are side by side, is it speed divided by time? No. Okay, only when something is on top and something is below, you divide them. But if they are side by side, you multiply. So that means distance equals to the speed multiplied by the time. Okay, students? So that's how we use the triangle. We use it to find, you can use this to find distance, you can use it to find speed, you can use it to find time. As long as you follow the triangle, you will always get it correct. So okay, average speed, units of speed. Now, when you talk about all this, we'll do some examples later on. We'll come across it here. So let's take a look. When you talk about speed, the units are very important because sometimes when you measure, what is speed? Okay, let me repeat, what is speed? Speed is the rate of change of distance. That means how fast does your distance change? How much distance can you cover in a fixed unit of time? So if your distance is in meters, then your speed is also going to be in meters. If your distance is in kilometers, then your speed is also going to be in kilometers. Now, if your time is in hours, your speed must also have hours, right? If your time is measured in seconds, your speed is also going to be in seconds. So that's why when you talk about speed, the units are very important. You need to know what is the units for your distance and for your time. So let me show you an example, okay? Over here, you're using kilometers and hours. What will happen? You will end up having your speed in kilometers per hour. So let's take a look. If I can travel 100 kilometers in 2 hours, what is my speed? Speed equals to the distance divided by the time. Looking at the triangle, remember this triangle? Speed equals to distance divided by time, right? Okay. Speed equals to distance divided by time, which is the distance of 100 kilometers divided by 2 hours, you get 50. But what is your speed? What is the units of speed? 100 kilometers 2 hours. That means your speed must be kilometers divided by hours, because you are taking 100 kilometers divided by 2 hours. So you will get kilometers per hour. Understand, students? Kilometers per hour. Now let's look at the next example here. 500 meters, 20 seconds. Speed equals to distance divided by time, which is 500 meters divided by 20 seconds. Get rid of the zeros. 50 divided by 2, you get 25 watt. 25 watt meters, okay, because the 500 is meters, right? This is meters, and this is in seconds, right? So you must say meters per second. So, just imagine that this line here is also divide. This line means divide also. Meters divided by seconds. It makes sense, right? Meters divided by seconds. Meters over seconds. So your units must be meters per second. So the units are very important. Don't get confused. If you give the wrong units, your answer is wrong. Okay, students? Any questions? Raise your hand. Anyone? No question? So what did we learn so far? We learned that we can use the triangle to find anything we want, right? You can find distance, you can find speed, you can find time. Whenever something is on top and something else is below, it means divide. It's just like fractions, divide. If it is side by side, you multiply. Okay? And of course, we learned that units are very important. You find out what are your units, distance and time, kilometers and hours. Then you get kilometers per hour. If the distance is meter, the time is seconds, then your units will be meters per second. So now that we have already seen the example, can I get you to do A, B, C, D? Okay. Type your answer. Make sure you include your units. Make sure you write down your units. Okay, I'm going to give you... Okay, before I start, Abby, you have a question. Yes, Abby.
My paper's different. Like,
okay, no problem.
It's like the same heading, but like the questions are different and like the information is different.
Okay, hold on. I'll settle that with you separately, okay? So, everyone, I'm going to give you 3 minutes. Can you do A, B, C, and D? Your time starts now. Do you have any answers yet?
No.
Okay, tell me, what triangle did I draw just now? What alphabets go into this triangle? Remember?
D, S, and T.
Yes, D, S, T. Very good. So if I want to find the speed, now let's see how to use this triangle. If I want to find the speed, speed equals to, look at the triangle, tell me.
Distance divided by time.
Distance divided by time. Time equals to?
Equals to this speed divided by distance.
What is on top and what is below?
Distance on top.
So when you write fractions 1 over 2, can you say this is 2 divided by 1 or 1 divided by 2?
1 divided by 2.
Okay, so the number on top divide by the number below. So can you read the triangle? Time equals?
Distance divided by speed.
Yes, correct. Distance equals?
Speed times time.
You are correct. Very good. Okay, so let's look at question A. Speed equals to what again?
Distance divided by time.
Okay, distance divided by time. So you want to find the speed of this ship. What divided by what? What is the distance? What is the time?
300 km is the distance.
Divided by?
5.
Yes, and you get 60. Now, what are the units being used here?
km. Day.
Very good. km per day. You are correct, Nicholas. Well done. Can we try the other one as well? The airplane. Okay, so we know that speed equals to distance divided by time. So what is the distance? Nicholas,
400.
sorry.
6,400.
And what is the time?
8 hours.
Yeah, very good. So 8 times 8 is 64, right? Okay, so 8 times 8 is 64. 64 divided by 8 gives you
8.
8. Then must you add back the 2 zeros?
Yes.
So what's the answer?
800 km per hour.
Wow, well done, Nicholas. Good job. Okay, let me ask Abby. Come, let's do this. Abby, speed equals to? Speed equal?
Speed equals to distance divided by time.
Yes, which is? What numbers do we write?
100 divided by 10.
That gives you 10. And what are the units?
Minutes. Wait, minutes per second. Wait, meters per second.
Yes, meters per second. Okay, well done. Because 100 is measured in meters. That's the distance, right? And the time is measured in seconds. Now, moving on to lightning. Okay, let's look at lightning. So what is this? Oh, what are we trying to find here? The speed of what? Over here, we are trying to find the speed of the sprinter. Over here, we are trying to find the speed of the ship. Over here, we are finding a speed of the airplane. And what are we trying to find here?
The speed of lightning.
The speed of lightning.
Thunder.
The speed of thunder. Which is it? Do you know? Are we trying to find the speed of lightning or speed of thunder?
Speed of
Well, I'm afraid it is neither, Abby. We are trying to find neither the speed of lightning nor the speed of thunder. What we are finding here is the speed of sound. Okay, Abby?
okay.
Now, the reason for this is because thunder is a result of the when the air in the atmosphere gets superheated by the lightning and some explosions occur. I don't really know, but something to do with that. So when lightning strikes, superheated air explodes and makes some sounds, and we call that thunder, right? Okay, so we know that. Can you tell me what is the fastest thing in this universe?
Light.
Yes, light. Light is the fastest thing in this universe, okay? So the time it takes for our eyes to see the lightning is very negligible. It's almost instant. When it happens, we see it, right? But it does take some time for if the lightning happens some distance away, and those superheated air explodes, it does take some time for sound to travel from where the lightning happens into our ears. So that's why we are saying, okay, we are trying to find the speed of the sound. So how do we find the speed of the sound here? Speed of sound equals?
Distance divided by time. So 640 over 2, which is 320.
Well done. Unit.
Meters per second.
You got it, Abby. Well done. Okay. Now, let me get Owen. Can you volunteer for part E and F? All right, Owen, let's find the speed of the snail. What is the speed of this snail? Something divided by... Sorry? Say that again. Did you just tell me this?
Yeah.
Why?
Because there's no way to divide it.
Okay, what are we trying to find? The speed, right?
Yeah.
Speed equals to
Speed equals to distance divided by time.
distance divided by time. Can
But
you?
how can 12 divide by 30?
Yes. And let's simplify the fraction. Can I divide 12 and 30 by a number? Which number do you want to use? What is the highest common factor between them? Both of them can be divided by 2, right?
3.
Both of them can be divided by 3, right? What
Oh,
about 6? What about 6? Can we divide them by 6?
okay.
Okay, let's divide both of them by 6. 12 divided by 6 is
2,
30 divided by 6.
5.
So what's the answer?
2 and 5.
2 out of 5 what?
Minute per, no, meter per minute.
Correct. Meters per minute, which is extremely slow. Wow. Can you imagine? This snail, he doesn't even travel 1 meter in 1 minute. He travels less than 1 meter in 1 whole minute. In 1 minute, I think you and I can already run 500 meters. Okay, let's look
I
at
can
the,
run 1 km already.
yeah, you can already run 1 km in 1 minute. No, I don't think so. Usually people take about 2 minutes. Usually
No.
people take about 2 minutes to run 1 click. Yeah,
What?
usually. Hey, no. 5 minutes. I think usually people take 5 minutes to run 1 kilometers if you are fast. If you're slow like me, I take 6.5 minutes to run 1 kilometer.
Well, my 1.6 I only got 7 minutes.
1.67 minutes. Yeah. That means you're quite fast. Wow, very good, Owen. Wow, not bad. Let's look at the bullet train. What is the speed of this bullet train?
The speed is 25 over 5, which is
Yes.
5 km per minute.
5 km per minute. Very good. You got the units correct. And the reason is because the distance is measured in kilometers. The time is measured in minutes. So your units will be kilometers per minute. Thank you, Owen. Well done. So students, so far it's very easy. You're just dividing numbers, right? Not? And it's all because of this triangle. This triangle helps you to find anything you want. So please remember this triangle, DST triangle, okay? Now let's look at example 2. Ken leaves home at 8 a.m. and he needs to reach the office by 11 a.m. So first, let's just count how much time does he have to travel to his office. He has 3 hours to travel to his office, correct? Now the distance from his home to his office is 258 kilometers. So if I want to find the speed that he needs to travel in order to make it on time, right? You are giving him 3 hours to travel this distance. So in every hour, how much distance must he travel in order to make it on time? You're just trying to find the speed. You're just trying to find the speed that he needs to travel, at which he needs to travel to make it on time. And you take 258 divided by 3, you get 86 kilometers per hour. That means he needs to travel 86 kilometers every 1 hour. Right? He needs to travel 86 kilometers every 1 hour in order to reach his office, which is 258 kilometers away. Now, students, can you just we can also use eating hot dogs. Eating hot dogs as an analogy. For example, you want me to eat 258 hot dogs in 3 hours. So how many hot dogs must I eat every hour? I must eat 86 hot dogs every hour for 3 hours. Then I will be able to eat 258 hot dogs in 3 hours. Okay, so don't think that speed is very much different from rate. Speed is also a type of rate. So let me mark this correct. And let's try to do the problem sums. Aha, so in question 2, they're telling us that there's this Karen, okay? So the Karen drives at a speed of what? 70 kilometers per hour from town A to town B, and this is 420 kilometers away. Upon reaching town B, Karen drives at a speed of 60 kilometers per hour from town B to town C, which is 320 kilometers away. They are asking you how long she takes for the entire journey. Please do not add up the distance. Please do not add up the distance. Now, let's refer to the DST triangle, okay? They are asking you to find how much time is taken. So if you look at the DST triangle, you know that time equals to distance divided by speed. What I'm telling you is, please do not add up the distance like this and you divide by the speed. Now, if you do this, you're totally wrong, okay? Because if you add this up together, you're telling me that her speed is 130 kilometers per hour. That means she's speeding, right? She's speeding very fast and the police is going to catch her, right? But at no point in time did she travel so fast, okay? Right? I don't think she has traveled so fast from A to C at any point in time. So please don't add up the speed. Please treat them as a separate journey. Treat them as a separate journey, 1 and 2. You go and find the time taken for the first part of the journey. You find the time taken for the second part of the journey. Then you add the total time together. That's how you should do it. Don't mix them up. They are separate parts of the journey, okay? So what about question 3? She was cycling in the park. How long does it take to cycle? Yeah, so students, using the DST triangle, you can also do question 3. I tell you what I'll do. I'm going to give you 3 minutes, right? First, I want you to solve the Karen question. Then I want you to solve the Nadia question. Remember to use the DST triangle. 3 minutes, your time starts now. Give me units in your answer. Give me units. Whether they're asking you to find the speed, you have to give me units. They're asking you to find the time. You must also tell me the units. Because time can be seconds, minutes, and hours. You can't just give me a number. If you just give me a number, I don't know what you're referring to. Are you talking about days or years, right? Or decades, right? I don't know. You must give me the units for your time. Okay? Okay, Renee. Now, why not? Now remember I told you that we should split the journey into 2. So this is part A. This is the first part of the journey. This is the second part of the journey. Okay. Now let's try to find the speed for the first part of the journey. No, actually, we are not trying to find speed. We are actually trying to find the time taken, right? So remember the DST triangle. How do you find time?
What?
How do you find time?
Distance divided by speed.
Yes, so we say time equals to the distance divided by the speed. Now, what is the distance here in the first part of the journey from A to B?
420.
So I say from A to B, the distance divided by what is the speed?
70 kilometers per hour.
Okay, so that will give us 42 divided by, get rid of the zeros.
6.
Yes, 42 divided by 7 is 6. So you get 6, what? 6 minutes? 6 seconds?
Hours.
Yes, how do you know it's hours?
Because it's not reasonable if it's 6 days or 6 seconds.
Yes, it's not logical, it's not common sense, right? But besides logic, what else can we use to tell us that this is measured in hours?
I don't know.
Look at the speed. Can you read this for me?
Oh, kilometers per hour.
What are they using? They are using hours, right?
Yeah.
So you see, if the speed is using hours, then let's stick to hours, okay?
Okay.
Okay, so now we have 6 hours. Let's find the time taken from B to C. And what is the distance?
320,
320 divided by?
60.
Okay, let's get rid of the zeros. And can we simplify this? 32 and 6. 32 and 6. What is the highest common factor?
3, no, not 3, 2.
2. So I divide this by 2. And I divide this by 2. Can I get a... So can you give me a mixed number?
Let me see, 5, 3 over 1.
Okay, so 3 times 5 is 15. The remainder is 1. So you have
3
5,
over 1.
3 over 1, like this?
No, I mean 1 over 3.
Yes, 1 over 3. And what is the units? The units of time?
Hour.
Correct. So what is the total time taken?
11 and 1 over 3.
Correct. You just add them up. 6 plus 5 is 11. And don't forget about the 1/3. So 11, 1 over 3 hours. Well done, Renee. How's it? Easy or difficult? Easy or difficult? So. Okay, well done. Now, what did we learn from here, students? We learned that if you want to know the units, you stick to the question, what the question is using. The question is using hours. So let's stick to hours. Don't change it to seconds or minutes or whatever. Stick to what the question is giving you. Okay? Now, let me ask Abby. Abby, can you try question 3 with me, Abby? All right, so over here, they're asking you, how long does it take for Nadia to cycle 1,600 meters? Now, if you want to know how long it takes for her to travel such a distance, do you need to know her speed first?
Yes.
Yeah, you definitely need to know her speed first because you're trying to find the time taken, right? To travel such a long distance. What is time? Time equals to something divided by something. What is it? Time equals to something divided by something.
Distance divided by speed.
Now you know the distance because they're telling you that she's going to travel 1,600 kilometers. But do you know her speed?
No.
So
But you know that she's gonna take the 88 meters in 11 seconds.
Yes, very good. So even though they did not give you her speed, we can find it. Am I right?
Yes.
So if we find her speed, then we can make use of the information to find the time. Okay, so let's find her speed first. How do you find speed? Speed equals to something divided by something. Distance.
Speed equals the distance divided by time.
Yes, distance over time. And what is the distance here in this case?
88 meters and the time is 11 seconds.
Yes, so you found that her speed is 8 what?
Meters
Meters
per
What?
second.
per second. Correct. Now don't
So
forget,
you,
this is meters. This is seconds. You are taking meters divided by seconds. So you have meters per second.
so you do 1,600 divided by 8.
Yes. Okay, time equals to distance divided by speed. 1,006 divided by 8 and you get 200. 200 what?
200 seconds. So then you convert it into minutes.
Very good. You convert it into minutes because the question is asking for minutes. So 200 seconds, how do you convert it into minutes? You divide it by?
Seconds is a minute, so you divide it by 60.
Correct, because a minute contains 60 seconds. You divide it by 60, get rid of the zeros. And can we simplify this 20 and the 6? Divide both of them by? What is the highest common factor? 20 and 6. Oh, you're muted. Can you unmute yourself? Divide both of them by what number?
2.
Correct. Divide this by 2. Divide this by 2.
10 over 3,
And
which is 3 minutes and 1 over 3.
correct, Abby. Very good. Well done. So, students, any of you have any questions about this? Raise your hands. As you can see, we again made use of the DST triangle. First, from the DST triangle, time equals to distance over speed. Then we realize that, hey, I need to know what is her speed. I need to know what is her speed. I went ahead to find her speed. So we went ahead to find her speed. Then we made use of the information to find the time. And the units are very important, students. Meters, seconds, meters per second. And since you are already using seconds, the time will also be seconds over here. So when you realize that this is seconds, then you can convert to minutes by dividing it by 60, okay? Any questions? Okay, let's look at question 4. Now, can I get Nicholas? Okay, Nicholas, let's try this together. Now, at 7:15, Jennifer leaves home. The bell rings at 7:50. So can we calculate, right? How much time does she have before the bell rings? How many minutes does she have before the bell rings?
$35.
Yes, she has 35 minutes before the bell rings. You want to find the speed at which she must travel in order to be on time. So speed equals to something divided by something. What is it?
Distance divided by time.
Yes. What is the distance in this case?
5,250 meters.
And what is the time?
35.
Okay. So let's simplify the fraction, okay? What number do you want to use to divide both of these? Both of these numbers can be divided by 5, correct? So 35 divided by 5 is?
7.
5250 divided by 5. You just split it up, okay? 5,000 and 250. What is 5,000 divided by 5?
1,000.
What is this divided by 5?
50.
So when you take 5250 divided by 5, what answer do you get?
1,050.
Yes, 1,050. Well done. So now we have 1,050 divided by 7. You just have to go ahead and divide it. Okay, you divide it, we'll get 150. What is the units?
Meters.
Meters per minute. You are correct. Meters per minute. So she must travel at this speed in order to make it on time. Well done, Nicholas. Good job. Any questions, students? Raise your hand. Any questions? No questions. All right, then let's take a look at question 5. Now, oh wow, we are doing space travel now. Okay, an astronaut sends a message back to planet Earth. And as you can imagine, an astronaut must be really, really far away from us, right? Now, students, how do you usually how do we usually connect our phone calls? We use radio waves, okay? So our phone calls will have a radio signal, radio waves. Radio waves are actually part of the magnetic spectrum of light. It is a type of light wave. Okay, there are many different types of light waves. There's UV rays, UV wave, radio wave, is part of the visible light spectrum. So radio waves travel at the speed of light. And that's how we communicate with each other. On Earth, because we are such a short distance away from each other, it is almost instantaneous. Right now, when I speak into my microphone, you are hearing me almost instantly, okay? But across vast distances, across the vastness of space, it does take some time for light to travel. The radio wave takes some time to travel at the speed of light in order to get back to Earth. And that's why we are trying to find out how long does it take for an astronaut to send a voice message back to Earth, or even if it is an SMS, it will take some time, okay? WhatsApp or Facebook message, it will still take the same amount of time. The same principles apply. Okay, don't get scared just because you see all these huge numbers here. What does all these huge numbers mean? Let me ask Owen. Owen, what is 2 to the power of 2?
4.
2 times 2. What is 2 to the power of 3?
2 times 2 times 2.
Very good. What is 10 to the power of 4?
4 times 4 times. No, never mind. 10 times 10 times 10 times 10.
Yes. Now, how many zeros do I get here?
You get 4 zeros.
Correct. I get 4 zeros. What about 10 to the power of 8? How many zeros do you think I will get here? Yeah. I have 8 zeros. Okay. So whenever we see this, okay, whenever we see this, we are simply just telling you how many zeros are there. Right, Owen? So if I write the number 2, 200, 2 times 10 to the power of how many? What do you think? 200 equals to 2 times 10 to the power of how many zeros are there in the number 200?
2.
Yes, so you just write 2. Okay, what if 2000? 2000. 2 times 10 to the power.
3.
Yes. What about 550? What about 55,000? 55,000 equals to
3.
5 times 10 to the power of?
3.
Yes, okay. What about if I say 5.5 times 10 to the power of? Can you guess?
2. Wait, I think I know this one before.
Oh, okay. Let me tell you why, okay? Because when you multiply by four zeros, 1, 2, 3, 4. So the decimal place will move here. So you get 55,000. All right, Owen? Okay, very good. All right, now everybody, I'm going to test you. Okay, everyone, I'm going to test you. Let me delete this. Oops. Yeah, let me just delete this first. Okay, so I have 200, 2,000. What if I have 55,000? I can write it like this. Okay, because you move the decimal 4 times. 1, 2, 3, 4. Then you get 55,000, correct? What if, students? Okay, if I have, let's say, 7, 2, 0, 0, 0, 0 equals to 7.2 times 10 to the power of question mark. Can you type what is the question mark in the chat? Everybody, can you count the zeros, move the decimal place? Move the decimal place, okay? Owen is giving me an answer. Owen, you are correct. Who else? Go and move the decimal place. Okay, like this, students, you see, I show you. Right now, the decimal place is here. 1, 2, 3, 4, 5. Then it becomes 7.2. Correct or not? So it will be 10 to the power of 5. Understand? Try again, try again. Let's say I have 911. 9.11 times 10 to the power of question mark. Everybody try again. Go and move your decimal point from here. Go and count. How many times must you move the decimal point? Okay, what number do I get? No lah, Owen is not 2 lah. How can it be 2? 911 times 10 to the power of what? Correct, Renee. Renee got it. Correct, Owen. Nicholas and Abby, what about you? 10 to the power of? Okay, I'm actually moving the decimal place. Okay, let's count together. 1, 2, 3, 4, 5. So this is 10 to the power of 5. Okay, last one. Let's test one more time, okay? Let's say I have 12300 equals to 1.23 times 10 to the power of. Okay, Nicholas and Abby, I want you to answer this. Nicholas and Abby, answer this. Nicholas, you got it. Abby, what about you, Abby? Can you type your answer? Abby, come. Can you unmute yourself? Do you know what's happening here? Hi, Abby. Abby, do you know what we're doing? Do you have an answer, Abby? Hello, Abby. Abby, are you there? Okay, so 1, 2, 3, 4, 10 to the power of 4. Now let's solve this question, shall we? Oops. Okay, there we go. Okay, it was glitching. You couldn't type. Okay, no problem, Abby. Now, let's take a look here. How long will it take? So we stick to the same concepts. DST triangle. They're asking you how long will it take, right? So if you want to find the time, you must take distance divided by speed. Time equals to distance divided by speed. And the distance in this case is 2.4 times 10 to the power of 10 divided by 3 times 10 to the power of 8. That is the speed of light. So students, it might seem so confusing. How am I going to divide this? It's so difficult. No problem. No problem. Okay, I tell you what. 10 to the power of 10 is 10 times 10 times 10 times 10 times 10 times 10 times 10 times, correct? It's just 10 times 10 times 10 all the way, okay? 10 times. So what we can do is we can split it up. Let's split it up, shall we? I'm going to split it up like that. 10 times 10. Okay, 10 to the power of 2 is 10 times 10. Then I'm going to split it up like that. So we are still having the same thing. We still have 10 tens. We still have, the total is still 10 tens. We still have 10 tens here. I'm just splitting up 2 of them. I'm splitting up 2 of them, and what am I going to do? I'm going to borrow this. I'm going to borrow this, and I'm going to combine it with 2.4. So 2.4 times 10 to the power of 2. What will happen? Okay, what will happen? You move the decimal 1, 2. You move the decimal 2 times. You get 240. So we end up with 240, right? Because I combine this together, and then you get divided by 3 times 10 to the power of 8. And guess what? Cancel, cancel. It's gone. So what's the answer? 80. What is the units? Okay, so 80 what? We're trying to find the time, right? We're trying to find the time. And what is the question using? The question is using seconds. Can you see? So we say that it takes 80 seconds to travel from, it takes the message 80 seconds to travel from the astronaut back to the Earth. All right. Anybody have any questions? Raise your hand. So actually, this is not difficult. In terms of concept, it's still the same. You're just taking your distance divided by your speed. But I think in this case, the thing that you are unfamiliar with is probably just the power of 10. That's all. Now let's look at question 6. Now this one requires a little bit of thinking. Okay. Can I ask Renee to volunteer for this? Okay, Renee. So you are a sniper. You are a sniper. You shot your target, right? So when you squeeze the trigger, what's going to happen? The bullet is going to come out of your gun, right?
Yes.
So the bullet is going to travel from where to where? The bullet is going to
What?
travel from where to where?
From your gun to the target.
Yes. Okay, from your gun. It's a very big gun. It's a sniper gun. From your gun, it's going to travel to your target. Okay, this is your target. And then you're going to hear the sound of your bullet hitting the target, right? So
Yeah.
what is traveling from the target back to your ears? What is traveling?
Sound.
Oh, very good. Something will come back to you. The sound of your bullet hitting your target will come back to your ears. Right? Now, the question says that after you pull the trigger, right? Then the sound of the bullet hitting the target was heard 5 seconds after pulling your trigger. It takes, so you only heard the sound 5 seconds after pulling your trigger. Yes or no?
Yes.
Okay, so you pull your trigger, right? You wait for 5 seconds, then you hear the sound. So when you pull the trigger, what happens? The bullet goes out, hits the target. Does it take time for the bullet to travel to the target? Yes or no?
Yes.
Yes, so it takes time. Okay, let's call this time number 1. Time number 1. It takes time for the bullet to travel from your gun to the target. And does it take time for sound to travel from the target back to your ears?
Yes.
Let's call this time number 2. So both of these take time. Okay?
Okay.
And what is the total time taken?
5 seconds.
Yes. The total time taken is 5 seconds. Okay, because after you squeeze the trigger, you need to wait for 5 seconds for everything to happen. And then finally, you can hear the sound. So time 1 plus time 2 equals to 5 seconds. They say given that the speed of the sound is 300, find the speed of the bullet. They're asking you to find the speed of the bullet. Okay. So now we understand the drawing already. Anybody don't understand the drawing? Anyone want to clarify what's happening in the drawing? Okay, now we know what's happening in the drawing, okay? Bullet goes there, it takes some time. Sound come back to you, it also takes some time. Okay, great. First, I would like to find the time taken because we already know the speed of sound, right? If you know the speed of the sound, can you find the time taken, Renee? Yes, you can. Because if you look at the DST triangle, time equals to what?
Distance divided by speed.
Distance divided by speed. Do you know the distance that the sound is traveling?
1,200 meters.
Correct. We already know the distance that the sound is traveling. Do I know the speed of the sound?
Yep.
So can I find the time taken?
Yes.
Yes. So let's say we find the time taken for the sound to travel. So it's distance divided by speed. What is the distance?
1,200 divided by 300.
And so it takes 4 what?
Seconds.
4 seconds for the sound to travel. So if you already know that the sound takes 4 seconds to travel, what is the time taken for the bullet to travel?
1.
Yes. The bullet took only 1 second. Okay, so when the bullet goes there, it takes 1 second to go there, hit the target, and the sound actually took 4 seconds to travel back to you. So the total is 5 seconds. Very good. Now I already know the time taken for the bullet. I want to find the speed of the bullet. How to find speed?
Distance divided by time.
What is the distance that the bullet travels?
1020 meters.
Divided by the time. How much time?
1 second.
Very good. So what's the speed of the bullet?
1200.
What?
No, seconds. No, meter per second.
Meters what?
Per second.
Correct, Renee. Very good. Well done. Do you find this easy or difficult?
Kind of easy.
Kind of easy. Very good. Anyone have any questions? Raise your hand. Okay, now let's look at Janine. She sees a flash of lightning. She hears thunder 5 seconds later. So, can I get Abby to volunteer for this? All right, Abby. So you see the lightning, you hear the thunder 5 seconds later. They're asking you how far was she away from the lightning? So you want to find, what are you trying to find here? Distance or the speed or the time?
Distance.
Distance. Look at the DST triangle. Distance
So
is
speed times time.
speed times time. Okay, so we say distance equals to speed times time. What is the speed?
320 meters
The speed of the sound.
times 5.
5 seconds. Oh, wow. Was this easy? Was this easy, Abby? Yeah, I think it's quite easy. Can you volunteer for the next one since this is so easy? Come, let's continue with the next one. Okay, conversion of units. Now, throughout this entire lesson, I've always been stressing to you that the units are important, correct? So let's see how to convert units. So Abby, let's take a look. They are telling us that the car can travel 108 kilometers per hour. So if you want to convert it, and they want you to find the distance it covers in 1 second. Okay, no problem. First, I would like to ask you, can I convert, find the answer in meters. Meters, okay? So they want you to give your answer in meters. So let's first convert 108 kilometers into meters. How many meters is this? Do you know?
It's 108,000.
Meters, correct. How do you know that it is 108,000?
Because 1,000 meters is 1 kilometer, so you work backwards.
Very good. Now, Abby has just said that 1,000 meters equal to 1 kilometer. Now, I want to tell everybody what is the meaning of kilo. Now, in measurement, okay, we use, whenever we have 3 zeros, we say kilo. Whenever we have 6 zeros, we say mega. Am I right? Wait, mega, I think so. And if you have 9 zeros, I think we say giga. Okay, so if I say, okay, I have 1 kilometer, that means 1,000 meter. What is 1 megameter, Abby?
Wait, 1 megameter in kilometers.
No. I'm just, whenever you see the word kilo, it means 1,000, okay? That means you add 3 zeros behind.
Oh, hundreds of thousands.
So if mega, that means you add 6 zeros behind. So 1 megameter is how many meter? You add 6 zeros behind the 1.
1 million.
1 million, right, Abby?
Yes.
And what is 1 gigameter? Then you need to add 9 zeros. So 1 gigameter is how many meters?
100.
No, 9 zeros is billion.
No, like 1 billion.
Billion. Yes. Okay, so in English, we call this million. We call this billion, right?
Yeah.
So you can say 1 billion meters, 1 million meters. Okay, can I ask you what is 2 kg is how 2 kilogram equals to how many gram?
2,000 grams.
2,000 gram. 2 megagrams equals to how many grams?
2 million.
2 million grams, correct. 2 gigagrams equals to how many grams?
2 billion grams.
2 billion grams. You are correct. So students, you just need to understand what is kilo, what is mega, what is giga. I think mega and giga, you will learn it next time when you are in secondary school. But for now, you just need to know what is kilo. That means you add 3 zeros, that's all. Okay, add 3 zeros, that's it. Okay, so we have found, we just need to, you realize that we just added 3 zeros and that's it, kilometer. So this is kilo. Kilo is 3 zeros, okay? So 1 kilometer is 1,000 meters. What about 1 hour? 1 hour, how many seconds are there in 1 hour? Or let's talk about minutes. How many minutes are there in 1 hour?
60.
And how many seconds are there in 1 minute?
60.
So what should I do to find the number of seconds in 1 hour?
3,600. You do 60 times 60.
Yes, 3,600 seconds. Okay, if I ask you to start counting from 1 until 3,600 seconds, you will finish 1 hour later. Okay, so this is 1 hour. So now we know that the car can travel a distance of 108,000 meters in 3,600 seconds. So if I want to find the distance in 1 second, how many meters can the car travel in 1 second? What must I do?
1
108,000. Then what must I do? We already, okay, what does it mean? It means that the car, okay, you look, okay, can we read this 108 kilometers per hour, right, Abby?
Yeah.
What does it mean? It means that the car can travel how far? 108 kilometers, right?
Per hour.
In 1 hour, correct?
Yes.
And we can also say that the car can travel 108,000 meters in how many seconds?
In 3,600 seconds.
Yeah, we know that the car is traveling 108,000 meters in 3,600 seconds. I just want to find out what distance, how many meters the car is traveling in 1 second. What must I do? I need 1 second only. I don't need 3,600 seconds. I just need 1 second. What can I do? Do you know?
No.
Okay, I can eat 10 hot dogs in 5 seconds. How many hot dog can I eat in 1 second? Abby,
Wait,
I can eat 10 hot dog in 5 seconds. How many hot dog can I eat in 1 second?
2.
How do you get the answer?
10 over 2 simplified.
10 divided by what?
10 divided by 5.
Yes, 10 divided by 5. Okay, if I can eat 100 hot dog in 50 seconds, how many hot dogs can I eat in 1 second?
20.
No, 100 divided by 50, right?
Yeah, right. 2.
2. Okay, now I'm telling you, okay, Abby, I can eat 108,000 hot dogs in 3,600 seconds. So how many hot dogs can I eat in 1 second? What must I do to calculate this? Abby, are you there? Abby? Oh. Okay, Nicholas, can you take over? Nicholas, what must I do to get the distance that I can travel in 1 second?
108,000 divided by 3600.
Correct. Cancel the zeros, cancel the zeros. Okay, so now we have 1080, right? 1080 divided by 36. Come, let's simplify it. Let's divide it by, let's see. Okay, you want to divide it by 12? Do you think we can divide it by, wait. Do you think we can divide it by 12?
Yes.
Then you get 90. 36 divided by 12 is 3. So what is 90 divided by 3?
30.
30. Okay, 30 what? What is the units?
meters.
You got it. Very good. So he can travel 30 meters in 1 second. So Nicholas, can we continue with this? Practice number 8. Sound travels at this speed. Convert the speed into kilometers per hour. Oh, okay. So over here, when you read this, right? Can I ask you, in 1 second, what distance can the sound travel?
330 meters.
So in 1 hour, they want you to find kilometer per hour. So they want you to find how many kilometer in 1 hour. Okay, so let's try to find 1 hour first. How many seconds are there in 1 hour? Remember how many seconds are there in 1 hour?
3,600.
Yeah, so I'm trying to find in 1 hour, 3,600 seconds, what distance do you think the sound can travel? You must multiply or divide?
Multiply.
Yes, okay, you multiply by how much?
3,600.
Yes, 330 times 3,600, and you will get, it can travel 1188,000 meters. Okay, so how many kilometers is 1188,000 meters? How many kilometers is this?
1188.
Yes, 1188 kilometers. Okay, because kilo means what? Kilo means
1,000.
1,000. Correct. So you just convert the 30 into the letter K and you are done. Okay, so now let's take a look. 1188 kilometers. So that means he can travel this distance In how many hours is this?
1 hour.
1 hour. So what is his speed? Equals to how many kilometer per hour? He can travel 118 kilometer in 1 hour, right? So what is his speed? How many kilometer can he travel in 1 hour? Do you know, Nicholas?
1188 km per hour.
Yes, that means he can travel 1188 km per hour. Well done. We have successfully converted meter per second into kilometer per hour. You have any questions, Nicholas?
No.
Very good. Thank you, Nicholas. Owen, can you volunteer for question 9? Okay. Owen, so far, do you understand question 8?
Yeah.
Okay, now you have a boat. If you are in still water, and there's no current, there's no waves, there's no current, then the boat can travel at 40 kilometers per hour. But if it is traveling against a 10 kilometer per hour current, what will happen? So this is the boat, right? 40 kilometer per hour. Then he's traveling against a current of 10 kilometer per hour. Then what do you think will what do you think is his speed? Is it still 40 or will it be slower?
With 10.
How much will it be? What will his new speed be?
10.
10.
Yeah.
10 is the speed of the wave. The current is pushing against the boat. The boat is trying to fight against the current. So what will his speed be?
30.
30. Very good. Okay, so he's fighting against the current. So he's going to be a bit slower. So the speed of the boat will be 30. So they want you to find the speed in meters per second. Meters per second. Okay, no problem. Meters per second. How many meters is 30 kilometer? How many meter is this? 30 kilometer is how many meter?
3,000.
30,000. Okay, 30,000 meters. Correct.
That's in like the 3 plus 9,000.
1 hour equals to how many seconds?
60.
60. No. 1 hour is 60 minutes.
Oh,
60 minutes.
many seconds is it?
1 minute have how many seconds?
3,600.
Okay, you need to times 60 2 times, okay? So then we have 3,600 seconds. So what does this mean? It means that the boat, right? The boat can travel 30,000 meters in 3,600 seconds. Okay? So if I want to find out the speed in meters per second, what must I do, Owen? In meters per second, what must I do? Must I times or divide?
Divide.
What divided by what? You are correct. What divided by what?
3600 divided by 30.
30, just 30.
No.
Okay, you must understand that. Can I ask you something? How many meters? How many meters can the boat travel?
Oh, what?
How many meters can the boat travel?
You can travel 10.
How many meters can the boat travel?
Meters.
It can travel 30,000 meters.
Yeah.
In how many seconds?
In 3,600 seconds. 3,600 divided by 30,000.
I think you are a little bit mixed up. I can travel in 3,600 seconds. I am able to travel 30,000 meters. What about 1 second? In 1 second, how many meters can I travel? What must I do? What must I divide what? Divide by what?
30,000 divided by 300 and
Correct. You must take 30,000 divided by the 3,600.
yeah, 8 meter.
Okay, so we take 30,000 divided by 3,600. You cancel away the zeros. And you have 300 divided by 36. You divide by 6. Divide by 6, you get 50. Divide by 6, you get 6. Right.
Yeah.
You tell me what is the fraction, or what is the whole number, what is the mixed number that you're going to get?
I'm counting. We're getting 8.
Sorry?
8 with the remainder of 48.
Remainder 48.
Yeah.
I think you are joking, right? 6 times 8 is what?
How much?
What is 6 times 8?
48.
What's the remainder?
2.
So, what must I write? 2 over?
2 over 6.
Can I simplify 2 over 6? Okay, and what is the units for this? What is the units?
MS.
MS, like this,
Meter
MS,
per second.
meter per second. Correct, very good. Well done, Owen. Okay, now express the speed of light in kilometers per hour. So, Renee, can you help me to do this? Let me ask you something. In 1 second, how many meters can the light travel?
3 times
10 to the power
10
of
to the power of 8.
meters, correct. In 1 second, this is how far he can travel. And I want to convert this into kilometers. If I convert into kilometers, I'll get 3 times 10 to the power of what?
8,000.
8,000. 3 times 10 to the power of 8,000.
Oh
Okay,
no.
what is 3 times 10 to the power of 8? That means 3 with 8 0. 1, 2, 3, 4, 5, 6, 7, 8. I want to convert into kilometer. How many zeros will I need?
5.
Very good. So times 10 to the power of what?
5.
Very good. Okay, because kilo is 1,000. 1, 2, 3. So this becomes kilo. K, kilometers. You are left with 5 zeros. You are left with 5 zeros. Well done, Renee. Now, kilometers. So I know that the light can travel 3 times 10 to the power of 5 kilometer in 1 second. So if I want to find the distance in 1 hour, what must I multiply?
3,600.
Yeah. I need to multiply by 3,600. Okay, so let's just say 3 times 3,600 3 times 3,600 equals to 10,800. Okay, so this times this equal to 10,800. So now let's just calculate the decimal point. I want to move the decimal point 1, 2, 3, 4. I want to move it 4 times. 1.08 times 10 to the power of, is it still going to be 5, Renee?
No.
Then what should it be?
10.
No. I'm only moving the decimal 4 times.
Oh, then 9.
9. Very good. So kilometers per what?
Hour.
Correct. Kilometers per hour. Because now we already convert this into 1 hour. And we also say that this is kilometers. So kilometers per hour. Very good, Renee. How do you find this? Easy or difficult?
I don't know.
Okay. Any questions, students? Anyone have any questions? Raise your hand. Okay, let's try example 4. Now, students, if I have a train, right, and it is trying to cross a bridge. Okay, let's say this is a bridge. Okay, now, if I'm just a man walking across the bridge, okay, let's say the bridge is 100 meters. If I'm just a man, I just need to walk. How far do I need to walk to cross the bridge? I just need to walk 100 meters. Then I already crossed the bridge. I've already crossed the bridge. That's it. But if you are a train, it's different, you know. If you are a train, then what will happen? Okay, you are the train. Okay, let's say you are a train. You're quite long, right? So let's say I am a train. Is it enough if I just walk? If I just go 100 meters, what will happen? Let's go 100 meters. Have I crossed the bridge yet? Or am I still on the bridge? I'm still on the bridge. Right, students? From here, I travel 100 meters. I'm still on the bridge. How do I cross the bridge? I need to continue, you know, until I travel the extra length of my own body. Don't forget, students, you must travel the extra length of the train's body. Then you have crossed the bridge. So you must take 100 meters plus the train's body. That is the total distance that the train must travel in order to cross the bridge. Anybody have any questions? Raise your hand. Anyone? Any questions? So let's try to solve this. So you have a train trying to cross a bridge. The length of the bridge is 320. The length of the bridge is 320. The length of the train is 180. So what must we do? The total distance that the train must travel is the length of the bridge, but you must also add in the length of the train's body. So how many seconds does it take? You want to find the time taken. Time equals to distance divided by the speed. So you must travel the distance divided by the speed of the train. And you realize that it will take 25 seconds for the train to cross the bridge. So we are still sticking to our DST triangle here. time equals to distance divided by speed. But what is the distance? Not only the distance of the bridge. Please add in the body of the train. That is the total distance that you need to travel to cross the bridge. Okay? Because the train's body cannot be on the bridge. The train's body must go off the bridge. So you must travel the extra distance in order to cross the bridge. So please take note of this. And then you find the distance divided by the speed. You find the time taken for the train to cross the bridge. Any questions? Raise your hand. Okay, then I give you 2 minutes, everybody. Can you try practice 11? Your time starts now. Please type your answer in the chat. So Nicholas, there's a train trying to cross the bridge. The distance, the bridge is 132 meters long. The train is 108 meters long. What is the total distance that the train must travel? Do you know?
240.
Okay, the total distance the train has to travel is 240. You are correct. Now, they want you to find the time taken to cross the bridge. So time equals to what divided by what?
Distance divided by time.
Yeah, distance divided by what?
Time.
No, DST triangle.
Speed.
Time, distance divided by speed. So what is the distance?
Distance is 240.
Speed.
12.
And we get 20. 20 what? What is the units for time? For the time?
Meters per second.
No. Time is meters per second. Then I ask you, hey, how long do you take to read a book? Oh, I take 10 meters per second to read a book. Does it make sense? Time is in what? How do you measure time? Meters per second.
Seconds.
Seconds. How do you know it's seconds, not hours, not minutes?
The
How do you know? Why? Why you tell me seconds? Where you get the seconds from?
12 minutes per second.
Minutes per second.
Meters.
Yeah, correct. Okay, seconds, because the question is using seconds. So we stick to seconds. Very good, Nicholas. Nicholas, can we try question 12 together? Okay, let's move on to question 12 together. Huh? Now, here we have two scenarios, right? The first scenario is crossing a bridge. They tell you that it takes 60 seconds. Okay, then the same train is going to cross a tunnel. Okay, and this time around it takes 90 seconds. Then they ask you how long is the train? What is the speed of the train? Do you know what to do? I give you 10 seconds to think. Any idea so far? No. Okay, never mind. Let me ask you something. What is the difference in these two scenarios? You notice that in these two scenarios, right? Okay, in the second scenario, what happened? The train traveled extra distance, yes or no? Okay, let's calculate what is this extra distance. What minus what? How do you find the extra distance traveled by the train? Oh, Owen, very good. No, Nicholas, can you tell me how to look at scenario number 1, scenario number 2? Can you tell me in scenario number 2, what is the extra distance traveled by the train?
2010 minus 1260.
Yes. The extra distance is 750 meters. And do you notice, okay, this is not the length of the train, students. This is not the length of the train, students. Okay, Owen and Abby, don't say that this is the length of the train, okay? This is just the extra distance traveled by the train. And Nicholas, do you notice that it also took some extra time for the train to travel this extra distance? Yes or no?
Yes,
How much extra time did it take to travel the extra distance?
30 seconds.
Yes. So do you think you can tell me the speed of this train now? How do I find the speed of the train? Speed equal to what divided by what?
Distance divided by time.
So let's take the extra distance divided by the extra time. And what is the speed of the train? Take away the 0. Divide by 75 divided by 3. What do you get?
25.
And what is the units?
Meters per second.
Correct. So we found the speed of the train. So now that we have already found the speed of the train, we can find the length of the train. Do you know how I can find the length of this train? Remember in the previous questions, what happened? In order to find the time taken for the train to cross the bridge, we actually needed to find the total distance traveled by the train. When we try to find the total distance, we need to take the length of the bridge plus the length of the train. Correct or not, Nicholas?
Yes.
So let me tell you something. In this question, did they tell you the length of the bridge?
No.
No.
Yes.
Yes, they told you the length of the bridge here. So you tell me, if I can find the total distance, right? And I minus the length of the bridge, can I find the length of the train?
Yes.
Very good. So let's try to find the total distance traveled by the train. So the total distance traveled by the train. You look at the DST triangle. How do you find the distance?
Speed times time.
Correct. Speed times time. Let's look at scenario number 1. Okay. The speed of the train is 25. We already found it. And what about the time taken? Speed times time. How many seconds? Scenario number 1.
60.
Yes. So this is the total distance. Speed times time. Minus away the length of the bridge. Then you get the length of the train. If you want to use scenario 2, we can also do it. The speed of the train times the time. What is the time taken in scenario 2?
90 seconds.
Minus the length of the tunnel. Do you believe that we will still get the same answer? Okay,
Yes.
the length of the train is 240. Very good, Nicholas. So, Nicholas, do you find that this question was tricky?
A bit.
Yeah. You have any questions about it?
No.
All right. Very good. How about the rest of you? Anyone have any questions about this? Raise your hand. Okay, let's do the bonus question. Okay, this is the last question that we're going to complete today. So, there is a rabbit and a hound. Okay, what is a hound? A hound is something like a dog, right? When the hound reached the finishing line, the rabbit was 10 meters behind. Let's compare them. Hound versus rabbit. When the hound completed, when he reached the finishing line, that means he completed 100 meters. Where is the rabbit? 10 meters behind. That means the rabbit only managed to run. Renee, can I ask you? How far did the rabbit run if he's 10 meters behind?
90.
90 meters. Very good. So now what happens? Now they are trying to say, okay, this is the starting line, this is the finishing line. Starting, and this is the finishing line. This is 100 meters. What are they trying to do now? They are trying to ask the hound to start behind. Okay, they want the hound to start behind, and he need to run a total of how much? What distance does he need to run if he's 10 meters behind?
110.
Yes. They want the hound to start 10 meters behind the starting line. That means the hound needs to run a total of 110 meters, and the rabbit is going to start from the starting line, correct?
Yeah.
Okay, who do you think will win? Everybody, can you guess? Type your answer. I give you 20 seconds. You can just think tell me who do you think will win. Type your answer in the chat. Everybody, and how about you, Renee? Who do you think will win? You can just tell me.
What if it was the same?
Oh, you think they'll finish the same, is it? Okay,
Yeah.
if you think it's the same, you type both. Okay, Renee already say both. What about Nicholas, Owen, and Abby? Owen say the rabbit will finish first. Rabbit say the hound will finish first. Oh, then Owen, you change your mind. You say both. What about you, Nicholas? Who do you think will win? Rabbit or the hound? Or both of them same time? What do you think, Nicholas? Type your answer inside the chat. Let's see who's correct, okay? Okay, let's start. Let's calculate and let's see who's correct. So students, from this diagram, we know that the hound is supposed to run 110 meters, correct, Renee?
Yeah.
Okay, fine. 110 meters. So let's simplify this. Let's try to convert this into 110. Okay? I divide by 10. If you divide by 10, you get 10, right?
Yeah.
The other side, you divide by 10, what do you get?
9.
Now, you want to make this into 110. What must I do? Multiply by what?
11.
So what do I get? Now multiply by 11, 110. Multiply by 11, what do you get for the other side?
99.
What does this mean, Renee? It means that when the hound have run this distance, 110 meters,
Oh,
then what distance did the rabbit run?
99.
Is it enough to reach the finishing line?
No.
No, that means when the hound finished running 110 meters, the rabbit only ran 99 meters. Who win?
The hound.
Very good. How far behind is the rabbit?
1 meter.
1 meter behind, correct. He almost made it, but he's too slow. Okay? So the winner
Okay.
is the hound. Well done. How do you find this question? Tricky?
Yes.
Okay, so students, what did we learn from this? Cannot just guess. You can't just guess. You have to write it down. You have to compare. Okay, you use the ratio. Just simplify it to 10 meters. Then you get your 110. Then you ask yourself, you can compare. The hound ran 110. The rabbit ran 99. It's obvious. The hound wins. Any questions? Raise your hand. Okay, so students, we have managed to complete today's worksheet. The very important thing we learned is DST triangle. Okay, DST, you can use it to find distance, speed, or time. And what else did we learn? We learned about the units. The units are extremely important. I keep on asking you, what is the unit? Please be careful with that when you solve your questions. Now, of course, we also did the questions about the train crossing the bridge. You must remember that the train is long, so you must include the body of the train. And also, finally, we did the bonus question, which is very interesting. Okay, so please go and do your revision. Get used to how to use the units. Get used to the units. The units are extremely important. I want you to get used to them so that next time you will write the correct units in your answer. Okay. Now, if you have any questions, you can stay back and ask me. If not, I'll see you next week. Bye, everybody. Bye, Nicholas, Owen, Renee, Abby.